Hi, welcome to the Fix Your Gut live stream. My name is Jason Hooper, and we're here with John Brisson.
Hi, everybody. Hope you're doing well.
Today, we're going to talk about SIBO and some of the causes and fixes for it. But just a quick ad here for Unfair Advantage. If you're one of our YouTube subscribers, we do a weekly drawing, and we're giving away a box of Unfair Advantage. So just as a thanks for subscribing, we'll send you a box if you win the drawing. Just the disclaimer, please make your profile public so that I can contact you. Otherwise, you won't win any Unfair Advantage. Also, if you don't answer your email, I'm not going to be able to send you Unfair Advantage either because I don't know who to send it to and I don't know what your address is. So there's the disclaimer. Hope you win. So how's your week been going, John?
Been doing pretty well. Been helping take care of my grandpa, trying to get him to recover. It's been off and on, success and failure. And my son started school, and the joys that come with that, and the germs, and everything else. So I did find it interesting that the school decided to send me a letter saying that I will be notified when they spray pesticides on school grounds due to some 2004 ruling, and they'll try to use the safest pesticide possible. So I thought you might find that interesting, Jason.
Yeah, what are they spraying for? Is it just like roaches and stuff?
Just whenever they have to, that they'll notify me and they'll try to use the safest, lowest toxicity preparation possible.
Like, okay.
I don't know. I just thought that was weird. I don't know if he had anything like that and heard anything like that in Texas or anything.
I mean, they could, and I just don't know it. I don't send any letters myself, obviously. I don't know if the school does. Your kid's in kindergarten this year or first grade?
Kindergarten.
Okay, so I don't know. They might have a different policy for younger grade levels. I don't teach that young.
And then, of course,
I'm certified EC through 12, but I only teach 5 through 12.
The school's a nut-free zone. Of course, on the topic of SIBO, we can talk about possibility of why people are allergic to nuts more now than they were in the past. But that's another qualms, because my son, when he brings his lunch, he has to have sunflower butter, which isn't the worst in the world. It is better for you than peanut butter, obviously. But
my next door neighbor's kid is so allergic to peanuts that if she contacts somebody, well, I guess this is allegedly, I haven't tested or documented this or anything, but according to them, if she touches somebody who's been eating peanuts, she'll develop a rash. Like, she's that allergic.
I never heard of anything that extreme. I'm not going to say that it's not possible. There have been instances of people exchanging bodily fluids and who are allergic to gluten, and their partner ate gluten and they came down with gluten sensitivity type reactions. So I guess it could be possible based off a touch alone. I'm a little, skeptic about that, but I'm not going to say that it's not possible.
Yeah, I'm kind of also, but that's what they claim. Yeah, and they have EpiPens all over the house, which is good because my oldest son today was playing in their backyard, and he got stung by a bee, and that's the first time he's ever been stung. So I guess it was a good place for it because there was EpiPens everywhere, just in case he would have.
Just in case he needed that adrenaline. Yeah, I got a real quick funny story about a wasp. I got stung by one, never knew that I did. My whole hand swelled up, and I took like half a box of Benadryl. You know normally how Benadryl makes you really tired?
Yeah.
It didn't. I guess it didn't, because all that histamine floating around through my body. It didn't make me tired.
Wow.
So, it's getting stung by wasps are not fun.
Yeah. Well, we took last week off because I have a newborn baby, so
congratulations, of course, from all of us.
I know you got some emails over that, but come on, guys, give me a week for my newborn.
It was very healthy and born naturally.
Yeah.
Old-fashioned way.
Yeah, we did we did a water birth thing.
Like Soviet Russia?
Yeah, we'll do a show on it sometime. I'm trying to get our midwife to come on and talk about it. She seems cool with it. She's just really busy right now. She has like 18 potential deliveries in the next couple weeks, so she's pretty overloaded. And she's also it was an interesting thing, and it'd be fun to talk about, I think. But we have to get her over here and get her on camera and stuff to talk about some things.
Sounds like it would be an interesting show. Wonder if she's got any crazy stories to tell.
I'm sure she does. I don't know if she could tell them, or maybe if she leaves out some of the details, but yeah, I mean, just the difference. Our first son, we went like the basic medical route with, the meds and the Pitocin drip and all this other stuff. And it was very invasive and very like barbaric. And then we did the natural thing, which was kind of like a free for all, do whatever you want within reason. And then, so the experience was extremely different. I mean, polar opposite for each one.
Yeah, all three of my children had to be born sadly through C-section. So.
Oh yeah, like in some states it's a law. Like if you've had a C-section, you're not allowed to deliver vaginally.
You could have one VBAC in the state of North Carolina, but we chose not to because Abel was so critically ill. It was best to do by C-section again.
Oh yeah. All right, well, that's cool. Let's get into our SIBO show because we got a lot to go over. So first of all, we're going to talk about what SIBO is. SIBO stands for small intestinal bacterial overgrowth, and it occurs when you have too many bacteria in your small intestine.
That would be correct, Jason. Some parts of our small intestine are relatively sterile, not all of them. The different sections. The duodenum is because it comes in contact with a lot of gastric juice and a lot of bile and pancreatic enzymes. So bacteria don't really like to live in the duodenum very much. Either do the stomach. Our stomach is relatively sterile too. Bacteria do not like extremely low pH. Acidic environments generally. So generally our small intestine is not supposed to have a lot of bacteria that dwell within it, and a lot of fermenting bacteria. Most of the bacteria that live in our small intestine like to break down proteins and fats. Mainly you got your E. coli living up there. You do have some lactobacillus living in your small intestine too as well. But the problem with SIBO is that the body naturally does not move the bacteria that we either ingest through, daily eating of food or just living, or bacteria that comes up from the large intestine that's supposed to get pushed back up into the small intestine. Motility is compromised. So that's pretty much what SIBO is. It's just overgrowth of a general area of the body, i.e. your small intestine, where bacteria are not supposed to really be there large amounts. And generally you also have the wrong types of bacteria, like fermenting type bacteria, especially carbohydrate fermenting bacteria in the small intestine.
So let's talk about digestion and the path the food takes and what's supposed to happen when, so that we can give our viewers an idea of what's going on and how SIBO might develop. So let's say we go to McDonald's and we consume a Big Mac, large fry, and well, let's drink a Dr. Pepper because we're going to be in Texas for this one. Everybody drinks Dr. Pepper here. So you eat your meal, you eat a burger, you eat the fries, you're getting a combination of different starches, sugars. You got the fructose from the soft drink. You've got the burger. It's got some protein. It's got all different sorts of fats. It's got fast digesting, slow digesting carbohydrates. So first of all, it comes in your mouth and you chew it. You masticate the food, and it's mixing up with your saliva, and you've got amylase, and it's acting upon some of the starches immediately in your mouth.
Correct.
But what if you don't produce amylase in your saliva, or what if you don't chew your food enough and you're just wolfing it down? Well,
a lot of those carbohydrates aren't going to do a crucial process in the step of digestion, because human beings don't produce a lot of amylase. Biologically through evolution, if you follow evolution, if you subscribe to the idea, human beings developed amylase as a way to taste, production in our mouth by saliva as a way to taste for sweet foods. But our pancreas really doesn't produce that much compared to other animals. And we don't have as many fermenting bacteria in our digestive system as, let's say, a cow or ruminant animal with 4 specific stomachs, where methane, archaea, ferment, live off the hydrogen that the bacteria produce when they ferment the grass. So human beings themselves, we're not the best in the world to equip to digest some starches and carbohydrates on chemical levels. So we rely on bacteria to break these down for us.
Yeah, I think cattle rely on the bacteria too.
They do,
which is why.
But the way their stomachs are designed, the way their gastrointestinal system is designed, our gastrointestinal system is more designed to break down protein and fats more efficiently than it is carbohydrates. Not to say that we can't break down carbohydrates, we can, but there's some things like cellulose which are indigestible mainly by the human body.
Yeah, so some of your cell wall, your double cell walls and stuff could be digested by the cattle because they have bacteria that can break it down. Correct. As they're going through the multi-stage stomach system. So, okay, let's say you don't chew your food, it goes down through the esophagus into the stomach. And then, so immediately a problem could occur if we don't get enough amylase through the saliva or we don't chew our food well enough. So once it goes from the stomach, we can have digestive problems there as well. So we just ate a Big Mac, large fry, and a Dr. Pepper, drank a Dr. Pepper. So in the stomach, we're supposed to have pepsin, and pepsidase, and
or pepsinogen, and when pepsinogen comes in contact with gastric acid, it turns into pepsin, and pepsin's used to break down proteins that it comes in contact with.
Yeah.
And pepsin also helps to keep the stomach somewhat sterile and inhibit a lot of bacteria that we ingest, because we ingest a lot of bacteria when we're eating food, a lot. And a lot of it has to do with, when you cook food, you're not killing everything because, it's impossible to do that. You're still ingesting food that it comes in contact by the time it gets to your mouth. All the safe preparation of cooking a food is just to knock down the bacterial levels and parasitic levels enough so that, your body can wipe out the rest without you getting sick or without it being able to produce toxins.
Okay, so yeah, you can, if your pH is off in your stomach, if it's too high, then you won't have, and you don't have enough bile salts, then it's going to mess up your digestion even more. So then you're going to have other food that's not digested right, and there's a lot of different causes of why we don't have enough stomach acid. If you don't get enough salt in your diet, sodium chloride, the chlorine molecule is used to create hydrochloric acid.
Correct.
Which is used to make your stomach more acidic. You can have problems with proton pump. We can have a lot of different problems with, I don't know, there's
stomach infections causing the body to produce less pepsin.
Yeah.
Pepsinogen.
Or we could have
H. pylori campylobacter infection.
Yeah, like acidophilic bacteria that neutralize some of the acid in your stomach and prevent you from creating more stomach acid so that it can thrive more. And so then your food's you're gonna be less likely to digest your food.
Proton pump inhibitors, medications, stuff like that too as well.
Yeah. Also, like if you have problems with your calcium channel,
yep,
that can mess it up too.
Calcium channel blockers have been shown to cause digestive issues. Or
just if you have a flux in your calcium channel because, I don't know, like you have a high exposure to EMF or something, like if you live by a cell phone tower.
There you go, Jack Cruz. That's the cause of constipation right there. Solved it.
Well, it causes a lot of problems. Too. But okay, so the food, let's go on. The food is gonna leave the stomach through gastric emptying and go
into the duodenum, the first part of the small intestine.
So because it's supposed to be a very acidic environment, and the duodenum, there are bile salts and enzymes secreted into the duodenum as well.
Well, yeah, to neutralize the stomach acid and the pepsin, you have to have bile, which is, more alkaline, of course, than stomach acid is obviously, and sodium bicarbonate, because you have to deactivate the pepsin because you don't want the pepsin to be digesting the mucosal tissue of the intestines. So the first part of the duodenum is sterile like the stomach, but the further you get down into the small intestine, which we'll talk about later, bacteria colonies start, becoming more rampant because it's very alkaline in that part of the intestines.
So so what can go wrong in the duodenum?
A lot of things. If the bacteria happen to survive the stomach and they come into the duodenum and there's not a lot of stomach acid or pepsin that was brought back into duodenum to be neutralized by bile, occasionally the gallbladder or the liver won't release enough bile into the duodenum. Bile itself has antimicrobial properties, directly affecting whatever it comes in contact with. So if you have less bile, you're going to have poor fat digestion, which could feed other bacteria who like to break down fat. And that's a problem right there. So your stools will come out yellow and smelly and, stick to stuff like peanut butter. So that can cause further problems down the line. And you can
that's kind of like what my newborns feces are like any newborn that's just
because they can't. That's why newborns have a high chance of getting bilirubin, because they can't start producing bile. It takes a little bit, so our stools are supposed to be from bile production, proper liver and gallbladder function are supposed to be dark brown. Usually you can tell someone's having liver issues or gallbladder issues if their stool is yellow or if their stool is completely white, like clay color, because there's no bile coming out.
So unlike the stomach, the bile is coming in through the portal vein, right?
Correct. Yes.
So if you're having liver issues, couldn't that also create problems?
Yeah, it would. I just said my father, who had hepatitis C, had extremely bad gastrointestinal reflux. Probably had SIBO too, underlying issue for years, but didn't really notice at the time. Because without a proper liver function, you don't get proper bile, and without proper bile production, it puts a big shunt into your digestive problem. And you start having issues. You either have dumping syndromes where you can have too much or too little bile, which can cause a whole host of separate issues depending on the symptoms and the amount of bile that's being produced or released and stuff like that. So bile is very important for proper digestive health, proper bile production. It's very important to prevent against SIBO, just like motility is, which we'll get more on motility in the MMC later. But it's always important for you to occasionally, as nasty it might be, to look at your stool and make sure that it's dark brown. Now, is it going to be dark brown every day? No, there are some things that you could eat to speed up your bile transfer to the point where not enough bile is released, like spicy food, for example. But it should normalize over a few days if you have a healthy digestive system. Even if you're eating spicy food or taking some sort of medication, your stools should hopefully turn back to being dark brown again.
Yeah. So go on Amazon right now and make sure to use the Fix Your Gut affiliate code if you've got it handy, and order just one of those like green fishnets so that you can capture your stool. You're going to want to bag it in a Ziploc, and you're going to want to freeze it because that's going to smell. So keep track of it and take a lot of pictures. They have like this MyFitnessPal thing just for your poop. You can post it and show your friends.
I want to make that my poop pal.
If you really want to diagnose the color of your poop, they sell these like color thing. It looks kind of like a mouse, and you hold it up to. It's like noobs use it to calibrate their monitors for doing graphic design and stuff. But you hold that up to your poop. Make sure to clean it off afterwards because there's going to be a lot of bacteria in poop, and you can get an accurate read on the color. What were we talking about?
We're talking about bile salts and how important they are.
What would happen if we had bacterial overgrowth in the duodenum?
You'd have a lot less bile salts being produced, and your stools you'll have a lot of what they call your typical gallbladder issues. Most people will have diarrhea, and it'll come out looking, of course, not dark brown. And also rifaximin is pretty much useless because rifaximin requires bile salts for solubility in the small intestine. So, in that case, do not use rifaximin because according to my just to the studies, it will do very little.
just a quick side note. I don't know why, but like one of my coworkers was diagnosed with staph. It turned out not to be staph, but guess which antibiotic they used?
Rifaximin?
Yeah.
Why?
No idea.
It would not do anything unless they had a staph infection in the intestines.
It was on his face. It turned out to be
You sure they didn't use rifampicin?
Yeah, I'm positive.
It was rifaximin.
Yep. I saw the bottle, but
anyway.
It's
not. It's huh? Okay.
It was dumb. All right. Anyway, so okay, let's move on. So okay, we ate the Big Mac, the fries, the Dr. Pepper, and we drank the Dr. Pepper.
The sugar from the Dr. Pepper should already be gone, right?
Yeah, it should be dissolved. It should have.
It would have only fed something in the stomach like H. pylori or anything, or Campylobacter, that upper gut, that would have lived off of it. But as far as the small intestine, never would have made it there. Correct?
If they have the proper enzymes to convert it to glucose, that would be possible. But not all
of it, because it's going to be high fructose. So some of it, if they're having small intestine digestive issues, there's going to be a lot of fructose malabsorption going on, because they're not going to have the enterocytes to piggyback the glucose to get it to the liver.
But yeah, it's going to be shuttled through the portal vein to the liver, because it has to be processed by the liver for us from the phospho-6 pathway, and that's really the same pathway that microorganisms would need to have also. Some do, some don't. Well, and that's part of the reason why some people get SIBO, is because the different bugs in our gut eat different stuff, and they have different genetics that allow them to process different things.
Like firmicutes prefer carbohydrates, bacteroids prefer protein and fat. That's why they say lean people have bacteroids more than fat people. Now, it could be genetic, it could be just depending on what people eat, but that's up for another discussion. We don't know too much about it yet. Dr. Perlmeyer, who I think is a great guy, and I agree with most of his research, very, very smart doctor. He talks a lot about it in Brain Maker and stuff like that. And Dave Asprey has too as well.
Yeah, I think a lot of it, though, has to do with intestinal permeability and LPS and endotoxin.
No, I agree with you on that, for sure. That.
Kind of the lack of, the sort of like the deterioration of the mucosal layer, the lack of butyric acid and short chain fatty acids that are being produced.
Yeah, because in the gingium, if the goblet cells can't produce mucus properly, you're going to have real bad leaky gut in the small intestine.
That's why that VO3 probiotic was so popular, is because of the claim that those microorganisms are producing butyric acid, and so and I think there was something about it on the Joe Rogan podcast.
Talk about colostrum butyric, I can't pronounce it. Clostridium butyricum. Sorry, even though my degree is in microbiology, I butcher everything because of my southern accent. But it's able to produce butyric acid, and it's normally found in the gut. All of them are, but I've had some bad instances with that probiotic, with people contacting me, having some issues with it, which I think it might be because of the Enterococcus faecalis, which is normal flora, but it can cause some issues with some people. I would rather most people get their butyrate from dietary sources when they have troubled guts than to try to implant more bacteria to try to get it to produce naturally on their own. I'd rather diversify later and try to supplement while they're ill. And you could also address the reason why the butyrophiles are dying and are not up to the proper ratios anyway. But okay, so let's go on from the duodenum. So we've eaten our stuff, leaves the duodenum. It's heading into the gingium, which is very alkaline. And it's where, like I said earlier, the goblet cells produce mucus. It's also you know, where some of our gut lymphoid tissue is located in. The same with the next part, which is the ileum. It's the last part of the small intestine. This is where leaky gut happens.
Yeah.
And I hate using the term leaky gut because I don't know. I mean, that's what it is, but not everyone who has SIBO, have I found, has leaky gut. I've coached someone personally who had excellent LPS markers, had no brain fog whatsoever, but still had SIBO. It's a head scratcher for sure, but I guess it could happen. They just have a really nice functioning immune system. You know, so this is the area, though, where the LPSs leak out and get into the bloodstream.
Yeah, and other things too.
Sure,
it's the most, well, I mean, probably it's the most vulnerable area usually, unless there's something bad happening.
Because it's one of the most alkaline areas. So bacteria do thrive in this part of the small intestine. But generally, the bacteria who live here don't ferment carbohydrates in large amounts. That's, you know, and produce, hydrogen. You know, this is where a lot of your methane produced archaea live. You know, and everything, and E. coli, like I'd mentioned earlier, and some of, you know, so this is where they hang out mainly, and that's the main problem with SIBO, is that the balance is overthrown. So when your meal's coming in here, it's, you know, if you do have SIBO, it's going to be feeding all these bacteria that generally do not belong in the small intestine. Like, staph lives in your nose. It lives in mostly all of our noses. You don't want staph
on my nose.
Okay, Jason. Yes, because
I take a lighter to it every hour.
Yeah, and
just to make sure.
Snort a little bit of isopropyl alcohol, just diluted.
Yeah.
Carpet bombing session.
I also don't have to trim my nose hairs because of that.
Good job, burns them right off. But you wouldn't want staph on a cut in your kneecap. You know, so
why not?
If your immune system is down, it would cause a nasty infection.
Yeah, that actually happened to me once after surgery.
So, you know, there are certain places where bad, scary bacteria live, where they're supposed to be. And that's the main problem with SIBO, is a lot of these hydrogen-producing bacteria aren't supposed to be here. And mainly, most of the time, why it happens, I would say the main reason is lack of proper motility. Now, it can be caused by a million different things, but if your NMC is functioning properly, those bacteria should either be pushed through the small intestine properly, or they should not be able to get back into the small intestine from a leaky or broken ileocecal valve.
And this is not a respirative environment, right?
No. This is an extremely, I mean, it's not as anaerobic as your large intestine's going to be, but it's still not supposed to be, you know, extremely aerobic either. You know, it's not, your large intestine is way more dense from microbes than your small intestine is, but the gingium and the ileum do contain a lot more bacteria than the stomach and duodenum do, and they're extremely sterile environments compared to the rest of your body.
But your stomach is, I mean, it's fairly respirative.
Yeah.
Duodenum, not quite as much for sure. All right, so you want to move on to the ileum? Have we covered the?
The ileum is just, it's pretty much similar to the gingium, is that it contains the majority of our GALT, you know, the pyre patches that produce leukocytes, which help, you know, combat opportunistic microbes in the gut. You know, this is where a lot of our immune system, which is weird to think that a lot of your immune system relies in the gastrointestinal tract, but it makes sense because it's our first line. You know, we eat pathogens, we breathe in pathogens, you know, we're swallowing all the time. Why wouldn't this be the first line, one of the first line of defense of our immune system for a whole body? And a lot of it's in this lymphoid tissue that makes up the bottom part of our small intestine.
Yeah, it also has to do with I'm sorry.
No, go ahead. No, go ahead. I was going to say that that's why for SIBO, people feel so bad a lot of the time is because they have an infection that affects the whole body. If you have an overgrowth of Klebsiella pneumoniae and it's able to escape, because Klebsiella is normal flora in the intestines. If it's able to escape through a leaky gingium or ileum where the gult's messed up and able to get into the bloodstream, it can travel into the joints and cause rheumatoid arthritis. It could travel into the spine, cause alkalizing spondylitis. It can displace itself in different parts of the body and mimic different diseases, which you understand, when I look at autoimmune diseases, I look at it as a microbiologist. And most autoimmune diseases have reasons that are caused by infection of certain microbes that are in places where they're not supposed to be. And a lot of it is in the gut.
Yeah, or they're attaching substrates to things that aren't supposed to be allergens and making them allergens. And
Correct.
That's kind of what I was going to go into next, was about the food allergens, or I guess like some food allergies.
Which Dr. Perlmeyer talks a lot about what you're about to talk about.
Yeah, so basically the same thing can occur, and I believe that most of it happens in the ileum too, is that if you end up with, you have bacteria that produce certain toxins, and sometimes the immune system attaches these toxins to useful molecules, or other substrates that either we make or comes in through food or something, and we absorb them because every molecule is keyed a certain way for transport. It's got to enter a cell or get out of a cell, and so and then the bad part of this molecule that's been attached to it just sort of comes along from the ride. So you have some kind of cytokine or something that ends up attacking the toxin, and the way it deals with it is it attaches it onto something else that's good, and then it gets into our blood. And so let's say you have that peanut allergy, the protein in the peanut, it would turn into a glycoprotein and then enter the blood that way. And that's where the anaphylaxis is experienced. But if we don't have, and the real thing is, if you don't have the meaningful amounts of bacteria that are participating in this process, that are creating these toxins, would you still have the food allergy, and would it be as significant?
I don't believe so, just because of Perlmeyer's work about non-breastfed children. Oh, not of his work, but I guess the data that he came together in his book, Brainmaker, about non-breastfed children and not C-section children not having, this bacteria that was properly given to them, which I think is a lot of the cause of peanut allergies, is because children are ingesting peanut proteins. Like we were talking about the digestive system earlier, the proteins aren't being broken down properly like they should be. And then, because their digestive system's out of whack, it's not being, broken down. So now you have these, proteins that would have been digested somewhat earlier in the past. Now they're not. Now they're larger molecules. And now you have this degraded mucosal barrier and gullet that's, inflamed and not working correctly. So the body either mistakes the protein as something else, or like, Jason was saying, it attaches as something else. It gets taken into the bloodstream, and then you have an anaphylactic type shock happen.
Yeah. But it's also important to bring up that all of these allergies are coming from what energy source? They're coming from protein exclusively.
Correct.
Not from carbohydrate, not from fats.
That's why some people with soy allergies can use soybean oil, even though I would argue to say not to do that, but they could, because soybean oil is so refined, there's very little proteins left in the oil itself.
Yeah, but it just depends on how allergic somebody is.
Correct. You're right about that. But some people who are allergic to soy can use soybean oil, even though I wouldn't do that, but they could. So I think a lot of it has to do with our, intestinal shape and health. And you would agree with me, wouldn't you, Jason?
Yeah, I mean, absolutely.
So, we have these tight junctures when we think of the intestines that are supposed to keep things out. The only time things are reversed where water is let in is if we have a cholera infection where the intestines do actually open the tight junctions up for a while and allow water to fly out to cause diarrhea through TRPV1 activation. Same thing about spicy foods, where it's kind of like a backlog. But other than that, we're supposed to have these tight junctions to keep, undigested proteins and bacteria out away from our precious bloodstream. A lot of people, when they have leaky gut, these junctions aren't tight anymore. And, the junctions require proper butyrate production by our intestinal bacteria for proper health. And a lot of people don't have these butyrate producing bacteria, and a lot of people don't consume high butyrate foods either to nourish so these junctions remain tight. A lot of people with bacterial overgrowth, there's 3 main short chain fatty acids that are measured. There's butyrate, there's acetate, which is also important to keep certain parts of the intestines more acidic, which helps bring down bacterial loads that are pathogenic, and proponic acid. And a lot of the propionates are linked to opportunistic bacteria like Clostridium. They produce proponic acid.
Yeah, so I guess let's keep moving along in the GI tract. Should we talk about the appendix next, or?
I honestly believe that the variform appendix has a purpose in the body. It was discovered by, the guy's name escapes me, and I would love to have him on the show one day. I believe it was from the University of North Carolina in Chapel Hill. The professor and researcher had discovered that the variform appendix served as a storage house of probiotic bacteria whenever a person would have a gastrointestinal illness. Usually when you have a gastrointestinal illness, the TRPV1 receptors are activated by toxins that bacteria produce, and it causes, or viruses in the form of viral gastroenteritis. And like I said, the junctions open up and water is allowed to flow through, and it causes diarrhea, which flushes your whole intestines out pretty much. And a lot of bacteria, good and bad, come out with that too. So our appendix is kind of broken off. It's at the beginning of what you call the large intestine, okay? And it's right after the ileocecal valve, all right? And it's right there, and it's kind of sheltered off a little bit, and when the MMC pushes stuff along, like diarrhea, the bacteria is supposed to stay there so that it can flourish back into your large intestine after you're ill, and you won't develop SIBO. Studies have shown that people without appendixes, when they have viral gastroenteritis, they have a 20 to 30% likelihood of developing E. coli dominated SIBO afterwards, because the bacteria status of their intestines without an appendix does not go back to normal.
So the appendix is attached to the cecum.
Yes, which is the beginning of the large intestine.
Yeah, and we like to think that everything flows in one direction. Everything flows out, right?
In a proper MMC functioning intestine, yes. The ileocecal valve closes properly, the gastric sphincters close properly, so stuff's not shoved back in through the stomach, through the duodenum, and everything flows mainly in one direction.
But anatomically speaking, the large intestine, we end up with like the transverse colon and how it comes up and wraps around.
Correct.
But at that part with the cecum, it's actually facing down. So
That's
it's facing down. The appendix is at the bottom. So
correct.
Food's coming out. Well, I mean, depending on your orientation, not like your sexual orientation or anything, but like your body's orientation. The food, like say you're standing straight up, so that the foodstuffs are passing this way, and then they got to go up, but the appendix is down here. So correct. We like to think everything just flows in a very linear fashion, but sometimes.
But if you're constipated, it doesn't.
Yeah.
Yeah. Food.
Well, think of like a siphon, right? If you've you got a siphon, you can have like a hose going in one and a hose going in the other, and you can take something up and down. And that's kind of what's happening in the large intestine, up with the transverse colon side, or I guess, I don't know which way I'm waving around, but
You're
anyway.
right. Yeah, you have these peristaltic waves that move fecal matter upward, but if you're constipated, they don't move in a timely fashion like they should. So fecal matter goes back down into the appendix. And what the researcher believes, and what I believe over time, is that's what develops into appendicitis. The infection of the appendix is because of constipation. Societies who squat, tribal cultures, have very few cases of any at all of appendicitis. It is mainly a first world disease. And a lot of it stems from our uses of using standard toilets instead of squatting. It's ridiculous.
Holy cow, man. Did you see those pictures that Cato Lotus posted on the Squatty Potty thread?
No.
And the bulletproof forums? Oh my gosh. So I guess they have a problem in England, and I guess like New Zealand as well, where they have people that are visiting through tourism or whatever. They're confused with the European toilets, and they try to squat on the top of the toilet basin, or I guess not the basin, but the bowl, and it breaks, and they break toilets. And so apparently they have a lot of broken toilets because people are doing this. But there was this one picture that he took of this guy who fell, and the ceramic part of the toilet like cut him up like horribly.
Ooh,
it's just a brutal looking picture of this guy just got torn to shreds, and he's sitting there on the bed just like bleeding out on it, and like the doctors are like, ugh.
So buy a squatty potty or buy some sort of platform. Don't stand.
You know what we should do?
I used to stand on my toilet. I used to do that.
Okay.
I don't do that anymore. I refuse to do it.
I wouldn't do it because and
if I'm out, if I have to use the bathroom and I'm out somewhere, it's going to have to be normal, non-squatting, and we're just going to have to do it because I'm not taking that risk. I stopped doing it because I was too afraid that I was going to fall into the toilet.
Well, yeah, I mean, and don't send any emails about racism or anything, but typically the Asians are a lot smaller than Westerners. If you take an average, and this is not racism, like if you statistically take an average of Westerners and their body masses, particularly Americans.
Yeah, Asians generally weigh less. Generally,
these are not big people,
no.
And so don't stand on your own toilet. But what we should do, like our next get rich quick scheme should be like a portable squatty potty where you could take it on the go and just like take it out of your purse or whatever and like set it up with the tripod stands, and then you're good to go.
That is pretty good. I like that idea.
Yeah. So if you're listening right now and you're like, I'm going to beat him to it, guess what? This is live on the air. So we're going to pull an Apple, and you're going to be Samsung. We're going to sue you. My idea first.
But I mean, Jason's right. There's also, I could do a whole show on the appendix. It's just, I can't believe forever people thought it was useless. The same researcher discovered that melatonin residuals in the appendix. We don't quite know exactly what melatonin does in the digestive tract like we do serotonin. We do have some instances that it might be used to close sphincters at a certain point in given time, like the ileocecal valve and the stomach valve. That's why melatonin works so well for heartburn. It would also make sense when you're asleep that melatonin would close sphincters because you wouldn't want, if you're laying flat, gravity's not going to help you too much with acid going into your esophagus if the LES isn't closed properly, just like a bottle of soda. If you turn it halfway, it's going to fill out. I guess the water bottle would work too, but it kind of would be like that. Compared to gravity keeps it down like that, and now it's uniform.
Is that alkaline water stuff?
Yeah, I have to drink it because my silent reflux, which, by the way, is the best I've ever had in my life. And I do attribute it to doing a couple of crazy things like drastically reducing EMF to the best of my ability and taking high doses of fish oil. So maybe Jack Cruz might be onto some things. But that being said, I guess we're going to have to do multiple shows on SIBO because we just barely scratched the surface on it.
Well, we still got 15 minutes. Let's just rapid fire through it.
Okay.
No, but yeah, we could do multiple shows. I know some people, like, they don't, the site's picture gut, and they prefer us to talk about some other things. instead. But gut health is extremely important. Gut health,
Oh, yeah.
like, probably has a greater impact. I mean, they're like, oh, we like the episode on nootropics, the one that got us almost banned from YouTube. But like, nootropics are cool and everything, but the amount of impact they have on the body is insignificant compared to what goes on in the gut. And so melatonin, I have my theory about melatonin in the gut also.
Go ahead. That's just for my own research. I would love to hear yours. Jack Cruz has his own.
Well, I think
Go
that
ahead.
melatonin, most of the melatonin in our gut are produced by the microflora, and I believe that it is a communication between microorganisms, and we just benefit from it. I would say haphazardly, but synergistically with that. So
No, I mean, I agree with you. That's one of the proposed. You talk about like with quantum sensing and stuff like that, using melatonin as a way to sense to one another. I mean, I definitely agree with you on that.
So yeah, like a single bacterium, if you study it under a microscope, it's going to have different properties. But when you start to get groups of them together and you get a large collection, we have what's called a genomic field that comes up. So since they're single-celled organisms, you can deconstruct their protein encoding genes, but that doesn't really tell you the whole story. Man, I'm going on a tangent here. But I'll blame it on the sleep loss due to the infant. But anyway, so you can't just look at the protein encoding genes and say, okay, this is the total extent of what this organism does. You can almost think of it like a multi-celled organism when they begin to grow in number, because they communicate with one another and they perform different genetic functions. And so that's why we call it the genomic field, because proteins become functional in another organism that's not created. And so it's not just proteins, but what the enzymatic proteins can create. So
Yeah.
they can create enzymes that can create other neurotransmitters, and like serotonin there's a lot of serotonin produced in the gut as well.
Correct. There is, and it's used for contraction and MC function.
It is, but what's producing the serotonin in the gut?
Bacteria are.
Yeah, it's not us. So
No, it's not us.
We have almost all of our usable serotonin in the gut is being produced by bacteria.
Just to move motility around.
It's not like our intestines producing this stuff.
Correct.
Yeah.
But my question to you is, as far as the melatonin, one thing I could not figure out myself, and maybe you have an answer for this, is we do a lot of our digestion at night too. So could the melatonin also work for contractions, even though I would think it'd be used to contract the sphincters? But what about the muscle contractions in the intestines as well? I mean, our MMC is doing some of its greatest work while we sleep.
So the MMC ultimately is regulated by the calcium channel.
Correct. That's correct.
And calcium is so
I would stay away from a calcium channel blocker, but continue.
Yeah, or EMF also, because
yeah, that's correct.
Said at the top of the show, EMF it modulates the calcium. It modulates calcium flux in the body, and that's bad because all of these ions are controlling a lot of things. You know, the calcium channel, the sodium channel, the potassium channel, and then the combinations calcium potassium channel, and we can go on and on from there. But it's not just like, it's not as simple as it seems. It's not like we're just like running current through our intestines. Like there are other substrates involved in the transport of calcium and what's going on. So you have these neurotransmitters like melatonin, serotonin, and other things that are interacting. Because if you think of the brain and why we have these neurotransmitters and these chemical, electrical impulses, it's because of a communication of neural relays. Yeah. Well, bacteria they don't have axons. They don't have this mechanism, but they still need to be able to communicate and function. And so that's kind of their, I wouldn't say makeshift, because they've been here longer than we have.
They're signaling molecules.
Yeah, it's part of what establishes the genomic field. And there are genomic fields in our body too, which is why, every cell in our body has the same DNA. Like the cells in your eyes have the same DNA as the cells in your bones.
Just depends on what pathways. It just depends on what pathways are activated and deactivated.
Right. So how does a cell know whether it's supposed to be a bone or whether it's supposed to be an eye? cell. And so, like, what if we start just growing bone in our eyes for some reason? You know, and
It can happen.
well, I mean, it could, but probably wouldn't because of the genomic layer in the
No, but I'm saying
eye.
it can happen in HRAS, like cancerous mutations. You can start growing tumors.
Yeah, like a paraneoplastic syndrome or something. Yeah, I see.
Yeah.
But let's just stick with simplicity right now, just for the sake of it. So, like the genomic fields to a multi-celled organism like us have different functions there, but in bacteria colonies, depending on the state of the colony and what's happening, what's needed, and maybe what's not needed, they communicate via these neurotransmitters, and as we benefit from them. So it would suggest that they were around before we were, because if we had a completely sterile gut, we'd be missing a lot of these key components that we need to thrive.
We'd be dead.
Yeah.
But I mean, you know, don't our mitochondria and our eukaryotic cells behave the same way too as well, because they were once bacteria?
Yeah, that's the theory that I believe, is that you know, that was the case, of where basically one species of bacteria absorbed another one, and it just kind of like, it didn't die, it lived within side of that, and they synergistically acted together, because our mitochondrial DNA and RNA are different than our biological, our cellular DNA, our nuclear DNA. So like, we get that from our mothers exclusively. So we get our mitochondrial DNA from mom.
Mitochondrial even all that stuff. But no, I mean, I agree with you, Jason. I guess we should have not called this episode SIBO. I guess we should call it the digestive system.
Oh yeah, I mean, just like rambling. Well, I was trying to.
It's good information. Hey, we gave out some good information in this.
Yeah, I mean, I was just trying to set the basis for like where we could end up with problems. So like, the food's coming down, and then we end up with overgrowth in certain places. Food isn't being digested, so we have an overgrowth of species, and then things aren't functioning properly. So if we have an overgrowth, and if we have an overgrowth in the ileum, it's going to create a siphon effect in the cesium, or the cecum, and things are going to be moving the wrong way, and we're going to have bacteria that's supposed to be in the large intestine that's going to be moving backwards into the
faulty ileocecal valve.
Yeah.
But I mean, you know, does a lot of it have to do with what we eat? Does any of it have to do with genetics?
Yeah,
as Jack Cruz says, does anything have to do with EMF and light exposure?
It probably doesn't have anything to do with the endosymbiosis theory that we were just talking about, but you know, it's a show. I guess we can go off on tangents, no problem. But the thing is, yeah, if we have a problem and there's food that should have been digested earlier, it's not going to be digested later because there aren't the enzymes to be able to do it.
And most time, all this is just irritate the gastrointestinal tract.
Yeah, so it's going to rot in your gut later on. Yeah, it's going to, and the bacteria are going to eat it. Like, what we don't eat or what we don't absorb and synthesize, they're going to. And that's, and so food, I guess, is not supposed to, certain starches are not supposed to be there. They're supposed to be absorbed earlier on. And if we have a lack of stomach acid, a lack of bile, a lack of amylase, all of that stuff can produce overgrowth. Where basically we're changing the rules in the gut to where bacteria are supposed to be competing with one another. But if we start feeding certain genetics, certain bacteria, they will thrive because they have an advantage over the other ones. It's like an evolutionary system. And these bacteria are living and dying so quickly that these changes happen hourly. That 3 hours after you eat a meal, your microbiome changes in your gut. Okay, so the good news is this stuff can be fixed because of that. Bad news is it can be damaged really quickly too. So, yeah. So,
I mean, Dr. Wesley Jones, he wrote the book Cure Constipation Now. I reference it in my book. He honestly believed that he had a mentor, I can't think of his name offhand, who taught him that if people had proper elimination, where they're going 2 to 3 times a daily, and it's brown, normal color, normal in the Bristol scale, that their body wouldn't be able to, like, if they had celiac disease, it might be a rare possibility within tune that they could eat gluten and their body not have any underlying mechanisms to react to the gluten itself. It didn't have enough time. Now, whether or not that's true or not, I don't know, but I do feel like that is an interesting theory that for MMC is functioning completely optimal, that, we could eat a lot of food and not have a lot of strong reactions to it. At least do believe that part is somewhat true. Now, if someone has celiac disease, I'm not advocating you eating gluten. I'm just saying that, the better your motility is, the least likely chance that you're going to have allergic reactions to food itself.
Yeah. So yeah, that's right. I don't think anybody should be eating gluten.
Yeah, I know, but I'm just putting it out there. That's all.
I mean, even if you don't appear to be sensitive to it, the data suggests that it does have an effect on you. It does. I mean, you are creating antibodies that you shouldn't be creating anyway.
But I mean, I do think this has been a very interesting, live stream, because a lot of people, when they talk about digestive health, they don't encompass everything, and that's what we try to do at Fix Your Gut. A lot of people aren't talking about LPS. We are, Perlmeyer is. It's really honestly about it. Not a lot of other people really are.
Rhonda Patrick was talking about endotoxin a little bit on some of her stuff, but yeah, I think we're gonna start to find out, and I need to continue on my endotoxin series on the blog, but we're gonna start to figure out that endotoxins are the cause of
most disease.
Yeah, I mean, unfortunately, and it's like, when I started biohacking or whatever, I wasn't that interested in gut health because I had good, like I have an iron stomach and my motility is great, maybe even a little faster than I want sometimes. And, so why learn about this stuff if I don't have a problem with it? But the more I read and the more I get into it, and, since sign on with Fix Your Gut and blogging and everything, it's like, oh my gosh, the reason why I've had such good health is because my gut's functioning right. And if it would stop functioning right, then I would go down, my health would drop dramatically. So, but I'm looking at our sheet here. We got about through half of our topic points inadvertently. But I mean, think about the book and think about the blog. How many thousands of words have you written about SIBO?
I can't even count.
And we're supposed to cover that in our show. So yeah, we'll definitely do a part 2. Maybe not right away. But we'll get to a part 2 eventually.
And if anybody has any questions about SIBO, definitely send them in. This is probably the topic besides silent reflux that I'm the most educated on. A lot because of my background and a lot just because of my interest in it too as well. I do believe a lot of our modern diseases stem from the gut. David Perlmeyer is very correct on that. And I wholeheartedly agree with him. And there is tons and tons of science to back it up. One day I'd like to do a show on autoimmune diseases that are caused by leaky gut. Crohn's disease and ulcerative colitis caused by Mycobacterium avium paratuberculosis. And, like Klebsiella pneumonia that I mentioned earlier, lupus and staph in the gut. But all those we could talk about on a future date. I'm pretty sure Jason would agree with me on a lot of those, and I'm pretty sure he feels pretty strongly, as I do, that MAP is the cause of ulcerative colitis and Crohn's disease for most people.
Absolutely. I am more sure than not that is the case.
Yeah, I've seen it in people I've coached personally in my own lives. My son's ex occupational therapist and a coach.
You're going to say your son's ex-wife or ex-girlfriend.
No, and my
son's 6. So.
A cook that I know at a local restaurant that I eat. One had ulcerative colitis, one had Crohn's disease. They both gave up all beef and dairy, and their symptoms just completely disappeared, went in remission.
Yeah, I mean, it sucks not eating beef or dairy, but it's an easy way to check. I mean, it'd be worth it if you have ulcerative colitis. It'd be worth it just to give those up, just to see if you have that genetic weakness to MAP.
Yeah, I mean, it's something simple you can do and see if you get better.
That's right. Well, thanks for listening, guys, and appreciate you cutting me some slack for taking a week off. to celebrate the birth of my newborn son. Again, we're giving away Unfair Advantage. This is good stuff. I'm mainlining this stuff right now because it's keeping me awake at my job when I've got kids that are screaming all night long. Because, you know, one kid sometimes wakes up the other kid, and it's a chain reaction.
I understand that. I have 2 kids. It's definitely like that.
So, like, if you've seen the movie Pulp Fiction, I just load up a syringe of glutathione. Like, I just extract it from all of the little capules, or what are they called?
Ampules.
Ampules, yes.
You really are that tired.
And I just, you know, just like, do I stab her 3 times? No, just stab her once, you know, and I just like take it right through.
You're having trouble with your brain compartments and your departments up in your brain, you know.
Yeah.
But
I don't know. Am I allowed to sing the Popeye song? We didn't pay for it.
We're gonna get in trouble.
Uh-oh. We're kicked off YouTube again. All right. Well,
I hope everybody takes care. I hope that, you know, SIBO is a very important, dear topic to me, and, you know, here at Fix Your Gut.
Dear.
So if you are suffering from SIBO, contact me, or if anything, join the support group on Facebook. Can help out a lot of people, and I've had recommend a lot of people to join that group because, you know, it is good to have camaraderie when you're dealing with such a severe disorder.
Yeah. Thanks for listening, guys. Have a good day or night, or whenever you're listening to this. Just have a good whatever.
Take care.
See ya.